Morning, Algebra 2 students. I hope you're all doing well. Hope you had a great weekend. The first thing we'll start with is we'll use long division to divide. So we're looking at taking this polynomial and we're going to divide it by this one here. So let's first write this out. The first thing that we write in front is we need to write what we're dividing by. So x minus 3. And that will divide into x to the third plus 5x squared minus 7x plus 2. And notice that each term is accounted for. We have the cube, the squared, the x, and the constant term. So we don't have to add any 0 x's. So the first thing that we do is we take the first term, x cubed, divided by x. So it looks like this. So x cubed divided by x, we get x squared. It means that we put it in the x squared column. Then we multiply, so we go x squared times x squared times negative 3. And then what's our next step? That's right, we need to subtract, which means switch the signs. We get 0. This becomes 8x squared. And then what do we do after that? Bring down the number. And then once we bring down the number, our next step is to, that's right, we need to repeat. So we have to repeat the steps that we did. We divide, multiply, switch the signs, subtract, and then we bring down the number. So let's keep doing that same thing. So again, this will be positive. Now we multiply 8x times x. Whenever we multiply that first term, we should get exactly what we had above it. If we don't, then we made a mistake. So 8x times negative 3 will be negative 24. Switch the signs. And then we have 0, 24 minus 7, 17x, plus 2 when we bring that down. And then now 17x divided by x is positive 17. That would look like this. Oops. 17 times x. 17 times negative 3. So think of it as 10 times 3 is 30, plus 7 times 3 is 21, so 30 plus 21. And then it'll be negative. And then our next step is to switch the signs. So we have 0. And then 51 plus 2, we have 53. All right, so then 53, can we bring down any more numbers? And then what do we do with this 53? That's right, that's our remainder. So we're going to add the remainder, 53, and then over what we're dividing by. So it's x squared plus 8x plus 17 plus 53 over x minus 3. So that's our fraction that we're adding to it. When we divide an x cubed divided by an x, we get an x squared. So our answer then ends up being a degree of x squared. And this is really a quadratic. All right, so if you're having troubles with long division, you can always go to office hours tomorrow at 1 o'clock to 3, and I can run through that with you again. You can also use the toolkit. This toolkit is attached to this assignment, so you will be able to see the long division here as an explanation. There's also a lot of videos out there on long division if either one of these isn't helping out. So today we're going to be looking at another way to divide. So first we did long division. Now we're going to look at something called synthetic division, and we're going to see how the simplicity of that, and this is actually the process over here. It looks complicated. It won't, this is just because they have all this stuff written out here. But so we're going to be doing this thing called synthetic division. Then we're going to compare both long division and synthetic division, and then we'll do some more practice. So students will be able to divide polynomials using long division, synthetic division, and again, that's so we can differentiate between the two methods. So we want to make sure that we can see what the two methods are and which one's going to work better when. And that's the real power of these two things, is when do we use one over the other. So synthetic division actually comes from this process. Back before calculators, people had a hard time evaluating certain polynomials. So if we were to evaluate this polynomial here, and you'll want to again add this to your notes. If we were to evaluate this, we would do 3 to the third. And then we would plug, again, we're just plugging the 3 in for the x's here. So we have plus 5 to the third, and then 3 squared minus 7 times 3 plus 2. And this is something that you could type into your calculator. We know that 3 cubed is 9. We know that 3 cubed is 27, 3 squared is 9. And then we have 5 times 9, which gives us 45. Negative 7 times 3 would be negative 21, plus 2. And then if we add these together, 5 and 7 will give us 12. Carry the 1, so it's really 72. 72 minus 21. So that would be 72 minus 21 would be 52. And then 52 plus, or no, 72, 51, whoops, 51. And then 51 plus the 2 gives us 53, and I should write a 53 here instead of 51. All right, so we get 53 when we substitute this 3 into this function here, 53. All right, so what this mathematician Horner decided to do is do some factoring here. So notice that you could factor an x out of these first 3 terms. So there's the x that's factored out there. And then what did next is that notice that, oh, I could factor out an x from here too. So then there's an x factored from that x squared. And they did use parentheses so that that it would separate out. And then if you substitute in here, the math is going to be a little easier. Notice that I was struggling a little bit, being like, oh, well, 3 cubed I shouldn't have. But like adding 27, 45, 21, 2 with the 53, it made it a little bit harder to evaluate there. But notice here it's a little different. 3 plus 5 is 8. 8 times 3 is 24. 24 minus 7 is 17. 17 times 3, 51. 51 plus 2 is 53. So notice that we get 53. They didn't change anything here. They just factored these x's out. So instead of writing it this way, though, they figured out this other way, and this is what you saw in the do now. So they take this, they make this partial box here, and what they're doing is the number that they're substituting in, a 3, they put it on the outside, and then we're just going to take all the numbers here. So there's really a 1 in front of the x, a 5, a negative 7, and a 2. So 1, 5, negative 7, and 2. And then we're going to do the same process that we did here. So the first thing that we actually did down here is we did 3 times 1. There's really a 1 in front here. That's this 1 here. So there's really a 1 there, and it was really 3 times 1. So 3 times 1. So what happens then is we take this 1 and we bring it down first. So that's the leading term. And then we do 3 times 1, and we get 3. And then they decided that what we're going to do is we're just going to add these columns up. So it's really that 1 just comes straight down first. And then you do 3 times 1, and we get 3. And then we add the 3 and the 5. So that was what we did here first, 3 plus 5. So 3 plus 5, we get 8. And that's what we had here. 3 plus 5 is 8. And then what do we do next? We multiply times 3, which is the original 3. So now we do 3 times 8, and that's 24. So then we had 24, and what did we do? We added it with a -7. So then -7 plus 24. So we always add the column. So -7 plus 24 is 17. And then what did we do with the 17? Then I had to multiply by 3. So I did 17 times 3. So 10 times 3 is 30. 7 times 3 is 21. So 30 plus 21, we get 51. So 3 times 17 is 51. And then we add 2 plus 51 is 53. So here it's like a little bit harder to see like what we're doing for a process when you just go across. But this way we can see things a little bit clearer. And then we notice that we get the same answer here, this 53. So this 53 is really what we get when we substitute. So when we substituted the way we normally do, we get 53. When we used Horner's method, we get it. And this is then synthetic substitution. And then we're going to see this theorem that tells us that 53 would really be this other answer that we can get if we did some division. So this next step we're going to have to take for what it says. So this is synthetic substitution. So we just take a number and we can substitute any. We can take any number. We can substitute a 2 in. If we use 2, if we want to know what is f of 2, well, we could do this process, or we could figure out that f of 2 is really going to be, we take a 2, we put up our thing here, we have 1, 5, -7, 2. So we bring the 1 down. 2 times 1 is 2. We add 5 and 2 is 7. 2 times 7 is 14. -7 plus 14 is 7. 2 times 7 is 14 again. 2 plus 14 is 16. So then if you insert in a 2, we get 16. I probably should have boxed this down here. This was our answer here, 53 and 16. So substitute any number in 1, you can get substitute to get the number. It's a fast way of substituting. But what we're going to use it for is someone realized that if you had a polynomial, so let's say we have a polynomial like we just looked at, and we divide it by a factor, so x minus k, then they noticed that the remainder was really if you substitute k into that function. So what we then notice is that when so let me leave that part up there. If we notice that when we divide polynomials, so this is our polynomial, if we divide it by x minus 3, so this would be f of x minus 3, then our remainder is really going to be the function substituted with a 3. So if we do synthetic substitution, and notice that this is what we just did, and this is the do now. So when we go down here, we notice that our do now was exactly the same. This is what we did for the do now. We divided these two things, and this is what we got. When we did synthetic substitution, this is what we got. So we substituted in a 3 because of this remainder theorem says that the remainder is going to be if we substitute that number in. And notice it's the same as dividing. So what we could really are going to be doing that is synthetic substitution really becomes synthetic division. So it's another way that we can divide polynomials. This polynomial, when we divide it by x minus 3, we get x squared plus 8x plus 17 plus 53 over x minus 3. What do you notice with our coefficients and the remainder with the numbers at the bottom here? That's right, they're the same. We notice that this 1 is that 1, 8 is 8, 17 is 17, 53 is the remainder. So what we really look at is this is our remainder, this is our constant term, this is our x term, and this is our x squared term. Now you can either do it by labeling this first one as remainder, constant x squared, but we also know that it should have started with x squared because it was x cubed divided by x. So that's why this should have been x squared. So if we rewrite this one, it's really going to look identical to here. So we have x squared. Notice that all the signs are positive, plus 8x plus 17 plus 53. That's our remainder. And remember, now look here, this is going to be something that might trip us up, is that this is a positive 3 and it's x minus 3. So if we leave and look back all the way up at the remainder theorem, it says x minus a number. So if you substitute in the opposite of what the factor is, or what that 0 would be. So it's going to be x minus 3, because that was what we really divided by. So it was x minus 3 equals 0. We want to figure out what x is going to be. So we add 3 to both sides. So we really want to substitute in a 3. So let's try out this process. So we're going to take this function and we're going to divide it by x plus 3. So first thing we want to do is we want to do x plus 3 equals 0. So then it's going to be x equals a negative 3 is what we're going to substitute in. Because if we substitute in, then we can get what our problem is going to be, or what we need to divide these two. So then we take that negative 3 and put it up front. Now we look at our coefficients here. So 2, 1, negative 8, and 5. So again, our process is, the first thing is we're going to bring down that number. Second thing is we multiply. So just like we did in Horner's method, we first multiplied the coefficient. So 2 times negative 3 is negative 6. Now we add the column 1 plus negative 6. Then we multiply negative 3 times negative 5. Add the column. Negative 3 times 7. Add the column. 5 plus negative 21. And then what we can do, just because we just did this for one of the first times, let's just double check, because it's pretty easy to make these addition or multiplying mistakes. So we brought the 2 down, negative 3 times 2. We added negative 3 times negative 5, positive 15. Added again, negative 3 times 7, negative 21. And then we add it again and get negative 16. So how do we do this? Well, we can see that it's x cubed divided by x. So this first one should be x squared. And then this one's going to be x constant remainder. Or you could go backwards. You always know this is the remainder. You could do remainder constant x squared. All right, so then let's rewrite it. So we have 2x squared minus 5x plus 7, and then plus our remainder. So negative 16 over x plus 3. Remember, it's a minus 3 here because we solved for it. So x plus 3. And this is another way to do division. So again, synthetic substitution, also known as synthetic division. All right, let's do another one here. Check our time. Oh, we got good time. All right, so just like before, now notice that this is x to the 4th plus 1 divided by x plus 1. So let's first do this x plus 1. So we want to set that equal to 0. We want to see what we're going to substitute in. All right, so we're substituting in a negative 1. All right, so for x to the 4th, we put a 1 in. Again, this is for x to the 4th. Now, where's the x cubed? So notice that we have to add a 0x cubed. We also have to add a 0x squared. We also have to add a 0x. And then a 1, right? So we have to put these zeros in 1, 2, 3 zeros. Just like before, we need to add a place for missing terms. And then 1. All right, so notice we have 5 terms across here, to the 4th, to the 3rd, to the 2, to the 1, to the constant. All right, so first step is to do what? That's right, bring down the number. Then what do? That's right, we multiply -1 times 1. And then what do we do after that? That's right, we add the column. So 0 plus -1. Then what do we do next? That's right, we multiply -1 times -1. Then what do? We add the column, so 0 plus 1. And then next, that's right, we multiply -1 times 1. And then, that's right, add the column, 0, -1. Then what do we do after we add the column? Multiply. And then what do we do next? Add the column. All right, and then we can just quickly double check this. 1, -1, -1, -1, -1, +1, 1, -1, +1, -1, -1, -1, -1 is 1, add 2. All right, so then what's our first term? This one here, which one's that? What's that going to be? That's right, it's x cubed, because it's x to the third divided by x gives us x cubed. So this will be x cubed, x squared, x constant, or x to the 0, and remainder. So we can rewrite this as x cubed minus x squared plus x, so it's 1 times x, minus 1, and then plus 2, and then over x plus 1. Great, so notice that it's bring down the number, multiply, add, multiply, add, multiply, add, multiply, add. And then so it's really just bring down the number, multiply, add, and then repeat until you get to the end. So then our final answer there was x cubed minus x squared plus x minus 1 plus 2 over x minus 1. Now, someone might say, well, long division might be faster than this one. So what happens if we did long division with this one? So we just write the setup, and then we do x divided, or x to the fourth divided by x will be x cubed. We already know we're gonna get the same answer, but notice the one method might be faster than another. So x to the third times x, we get x to the fourth, x to the third times 1, x to the third. Then we switch our signs, negative x cubed, bring down our 0x squared. And we do the same thing, divide. So we have negative x cubed divided by x will be negative x squared times x. Negative x squared times 1. Switch the signs. Bring down the number. So you can see that this one you're writing a lot more. It's possibly may take similar time, may be faster. This one is maybe a little quicker. And notice that what we're doing is we're only dividing by something that is just an x plus some sort of number. So whatever that number may be. Notice that we were not dividing by x squared, and we'll see that we actually can't divide by those ones. So as you're doing well, first we'll look at some corrections to practice one. So notice in this one, we could have done synthetic division with this. We could have taken x minus 4 equals 0, so x would equal 4. We could do synthetic division with this one, and we can see we'll get the same thing. So 1, negative 17. So we bring down the 1. 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. Negative 17 plus 20 is 3. So then again, x squared divided by x will be x, constant remainder. So we really have x plus 5 plus 3 over x minus 4. So notice that we get the same thing with both processes, but which one is going to be quicker for you? Is it going to be quicker to do this one or with long division? And the more you do one method over another will make one quicker than the other. Which one lends to the least amount of mistakes? So be thinking of that as well. All right, so let's just look at the rest of these. For 2x squared plus 4x plus 7 plus 9 over x minus 1, and then this last one here. So like I was saying before, this number 3 wouldn't be possible to do with synthetic division unless you could factor this part first and then figure it out from there, but this one doesn't factor. But if it did factor, you could divide those factors, and we'll be looking at that in the future too, in future lessons. All right, so here's the 3 problems. So in your homework tonight will be to do 6 problems. So this first one, you're looking at the synthetic division that happened. And then what you're looking at is you're explaining what do the numbers in the bottom represent. So what do these numbers mean down here? And then you can also look at your toolkit notes to be helpful to, and notice that this one says divide using long division. So divide this one using long division. And then 3, 4, 5, and 6, they say use synthetic division. So again, use that synthetic division, practice that. And if you need to, make sure to check out your notes. Also, you can check out the toolkit. So the toolkit is also has the synthetic substitution division method. So the first one, it just says evaluate f of 2. And you remember that we did this one to get 16. But you can also, it uses that as division as well. So if you solve for that -2, so we're really substituting in the -2, and we're going to get the same remainder, so that 28x plus 2. So this is a good way to divide. And again, I'm writing out way more than you would need to if you're, all you would have is this part here, really for the written out part. All right, and then we have our ticket out. That was yesterday, or last class. All right, so describe your steps to dividing polynomials using synthetic substitution. So write those steps out. What do you do first? What's the setup? And then again, that's going to help with your memory. And then how confident are you in dividing using synthetic substitution? So maybe you still have some questions, so you're somewhat confident. Maybe you're not sure at all and you have to go back and check it out again, then I'm not confident. But if you get it, put confident, what is your evidence? State those parts as well. All right, and have a great day. I hope you're all doing well. Reach out to me if you have questions. Again, today, 9th period. So 9th period from 2 to 4. And then there's office hours tomorrow so this would be Tuesday. That's today. And then tomorrow, Wednesday, from 1 to 3. If you have questions on dividing polynomials using synthetic substitution. All right, have a great day. Talk to you later.